This morning, we're going to talk about how we can incorporate what we learned yesterday with side, 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 and side angle side, and we're going to incorporate that in proof form now. These proofs, pretty similar to the proofs that we've done with our T-column proofs, and I'm going to show you some little strategies that you can utilize as you're working through these. But for each one of these, we are going to make a little T-column proof. So this first one, we've got that AB is congruent to XY, AC is congruent to XZ, and BC is congruent to YZ. Now, just so that you know that you've got enough information on these proofs to prove what they're asking you to prove, I'm going to suggest that you use a small letter S for any sides that are congruent and a small letter A for any angles that are congruent that you write in your proof. So hopefully you notice here in this first statement, AB is congruent to XY. Now they've already marked this in the picture. So that is one pair of sides. And put a little S there. AC is congruent to XZ. That's another pair of sides. So I'm going to put a little S there. And then BC is congruent to YZ. That's another pair of sides. And once I know that I've got three pairs of sides, we learned yesterday that that is simply side, side, side. So I have enough information to show that triangle ABC is congruent to triangle XYZ. And that would be by side, side, side. Okay, let's go ahead and look at number 2 now. If you go to slide with proof number 2 on it. And we're going to go ahead and set up our T-chart. So we've got that AB is congruent to CB, and D is the midpoint of AC. That's our given. So I'm going to first start with my first statement. AB is congruent to CB. If I go up to my picture and mark that, that gives me one pair of sides in the two triangles. Our second statement, D is the midpoint of AC. Now this is going all the way back to chapter 1. Utilizing our definition of a midpoint, we know if D is the midpoint of AC, then I can state that AD is congruent to CD. And that's definition of a midpoint. That gives me another side or pair of sides. So I'm going to put a little S next to that statement. Now at this point, we either need another pair of sides or we need a pair of angles. For statement 3, we can say that DB congruent to DB. And that gives me my third side. That's reflexive. It's our reflexive property. And now that we know that we've got three pairs of sides, we can now say that triangle ABD is congruent to triangle CBD. And that would be side, side, side. Okay, let's go ahead and see if we can fill this one in. So we've got RS is congruent to TS. Again, that's marked on my picture, so that gives me one pair of sides. We've got V as the midpoint of RT. Can somebody tell us what we can conclude from that? Either type into the chat or okay, so Aiden's typed in that RV is congruent to VT, and that would be definition of midpoint. I'm going to mark that in my picture. That gives me another pair of sides. How about our third step? Okay, again, typed into the chat, VS is congruent to VS. That gives me another side that they share. That's going to be, again, reflexive. And just like the two previous problems we've done, we have three pairs of sides. We can say triangle RSV is congruent to triangle TSV. Side, side, side. So here we go. On this one, we're going to go ahead, just like the other ones, we're going to fill in our given. Now this should say that AB is congruent to CD, so I'm going to add that little tilde there. AB congruent to CD, and AB is parallel to CD. And we notice AB and CD are already marked in our picture. That's one pair of sides. Now, as I look at this, we're trying to prove these two triangles congruent. So what we're going to say in step 2 is we're going to say that angle BAC is congruent to angle DCA, and that is if lines are parallel, alternate interior angles are congruent. So that gives me an A, or a pair of angles. Now, hopefully you recognize now we've got a pair of sides and a pair of angles. So we either need another side, which we know that they share this side, so that's a good step. We could go ahead and say that AC is congruent to AC. So that gives me another pair of sides by reflexive. And I can now then prove the two triangles congruent. If I mark those beside there that they share, triangle ACD congruent to triangle CAB by side, angle, side. Okay, let's go ahead and go through this and see what you've come up with. So let's start with the first given. V is the midpoint of YZ. Can somebody tell us what we can conclude from that? So very good. We can say YV congruent to VZ. That's definition of midpoint. I'm going to go ahead and mark that in my picture. Same, kind of the same thing with the second sentence. V is the midpoint of WX. So hopefully you stated that WV is congruent to VX. That's also definition of midpoint. So in my proof here, I've got two pairs of sides. Put little S's next to those statements. So now I either need a third pair of sides or I need a pair of angles. Now, one of the things I'm just going to show you in this picture that might make it a little easier for you, I'm going to put numbers in here on these middle angles just to make it a little easier. You don't have to do this, but it helps you because we know that these two angles are vertical, so we can say that angle 1 is congruent to angle 2. You could have also said angle XVZ is congruent to angle WVY. That would be the same thing, but that gives me a pair of angles. That's all vertical angles congruent. And now as I look at this, I've got two pairs of sides and then a pair of angles. I can now state that triangle XVZ is congruent to triangle WVY, and that would be by side, angle, side.